to be talking about graphing polynomial functions, and this is day 2. We actually are going to graph a polynomial function, and especially using the in behavior is going to help us out a little bit in actually graphing and finding the shape of the polynomial. All right, so we have a polynomial function right here. It's a negative x to the third plus x squared plus 3x minus 3. So this is in standard form, so we can go ahead and start graphing. Okay, now what I want to do first is a table of values, So let's do x, then I'm going to use that up there, and then our y. And I'm going to use 5 points. And the best 5 points to use is our -2, our -1, our 0, 1, and then 2. Those are the best ones to use right there. So let's plug those in. Need a little bit more room on that one. There we go. Okay. This is going to give us 3. All right, our next one is our -1. Let's plug that in. And that gives us a -4. Let's plug in 0 next. That gives us a -3. Plug in 1. That gives us a 0. And the last one, we're going to plug in 2. And that gives us a -1. So we're going to graph these. We're going to plot them on the graph. So we have a -2, 3, a -1, -4, a 0, -3, a 1, 0, and a 2, -1. Okay, and what we're going to do is we want to see where this ends up. We've got to figure out the end behavior. Well, to figure out the end behavior, we have to know the degree, which is odd, and the leading coefficient, which is negative. Okay, so we're going to look back at our chart from yesterday, and we're going to see where that end behavior is going to be for an odd negative. So for an odd negative, as f of x approaches positive infinity, x approaches negative infinity. And then f of x approaches negative infinity as x approaches positive infinity. Okay, so that means this will go up and to the left, and we're going to just connect these dots, making a nice curve, and then as y approaches negative, there we go. And that's how we use our table of values and our end behavior to graph our polynomial function. Let's try another one of those. All right, so we're going to do a table of values once again. All right, that should be large enough. And we are going to do a -2, a -1, a 0, a 1, and a 2. And let's plug those in. So we have a negative 2 to the 4th minus negative 2 to the 3rd minus 4, negative 2 squared plus 4. And that's going to give us a 12. Next one, we're going to plug in a negative 1. So we have a negative 1 to the 4th minus negative 1 to the 3rd minus 4, negative 1 squared plus 4. And that's going to give us a 2. Our next one is 0. 0 to the 4th minus 0 to the 3rd minus 4 times 0 to the 2nd plus 4, and that will give us a 4. Our next one is going to be 1. 1 to the 4th minus 1 to the 3rd minus 4 times 1 squared plus 4, and that will give us a 0. Our next one is going to be 2. 2 to the 4th minus 2 to the 3rd minus 4 times 2 squared plus 4, and that will give us a negative 4. Then let's figure out what the end behavior is. So our degree for this one is going to be an even, and the leading coefficient is going to be positive. So we're going to look at our chart for an even positive. So let's write that down. F of x approaches positive infinity as x approaches negative infinity. And then f of x approaches positive infinity as x approaches positive infinity. All right, so let's graph these on here and then sketch the end behavior. So we have a negative 2, 12, which is about up here, negative 1, 2, 0, 4, 1, 0, and 2, negative 4. Okay? So let's graph this. This is going to be positive, going upwards. So it's going to be going that way. And then it goes up, and then curves down, and then back up again for those end behaviors because f of x is going positive for both ends. All right, next up, what we're going to do is we're going to be able to describe the intervals for which A, f is increasing or decreasing, B, f of x is greater than 0, and C, f of x is less than 0. So we're going to be looking at this graph, finding these pieces of information. So let's look at this. So for the first one, A, we have to figure out where f is increasing. So if we look at this, this graph is increasing from here to here. And the way we write this is f is increasing on the interval negative infinity, comma, negative 4, because it goes to the negative 4. And then decreasing on the interval. So if we look at this, it's going from negative 4 and decreasing to positive infinity because it's slowly approaching the positive area of the x number line. So that's going to be a negative 4 positive infinity. All right, the next part, B, is we have to find the interval where f of x is greater than 0 or positive. So that means it's going to be from here to here. So that's going to be a negative 6, negative 2. The last one is where f of x is less than 0. So that's going to be the negative area. So it's going to be from here to here and from here to here. So we have two intervals for this one. The green one is going to be a negative infinity, negative 6. And then the red one is going to be negative 2, positive infinity. So that's how you read your graphs and being able to describe the intervals for those.